Right. Let's jump straight into this explainer and tackle a massive, fatal exam trap. It's one that literally costs Cambridge IGCSE computer science students critical marks year after year. We're talking about TCP, the Transmission Control Protocol. Now, most students think they've got this nailed down, right? But honestly, their actual exam answers tell a completely different story.
Take a look at this classic generic student answer. TCP sends data over the internet. I mean, sure, it sounds fine if you're just chatting with a friend, right? But put that on an exam paper and you are getting absolute 0 marks. Why? Well, because it completely ignores the actual technical mechanism. It literally tells the examiner nothing about how the data is handled, what rules apply, or why any of it actually matters. So today, we're going to fix that. We are going to completely bulletproof your understanding.
Okay, part 1, unlocking TCP concepts. This is really the absolute core of interconnectedness.
So to fix this massive grade boundary risk, we really have to wrap our heads around the fact that computer networks are built entirely on the foundational principle of interconnectedness. The crucial point here is the TCP/IP isn't just about, sending data out into the void. It is a highly specific, rigorous protocol suite. Think of it as the absolute rules governing exactly how data packets are transmitted, how they're routed through this massive web of communication pathways, and finally, how they're received. The absolute keywords you need to remember here are reliable and error-free. Basically, TCP ensures that a file sent from, say, Tokyo arrives in London completely intact without a single missing bit.
Let's break down exactly how this builds. You see, data doesn't just fly across the network as one giant file. No way! First, it gets systematically broken down into these small, manageable chunks. We call them packets. Second, these packets are transmitted and routed independently. They might even take completely different paths to get to the exact same destination. It's kind of like a giant puzzle. And third, TCP steps in to ensure they're all received and reassembled error-free in a guaranteed, orderly fashion. Oh, and if a packet gets lost along the way, TCP instantly demands a retransmission.
Now, obviously, these protocols don't just exist in thin air, right? They rely on physical, underlying transmission technologies, which broadly fall into 2 categories. First up, we've got broadcast networks. These utilize a single shared communication channel for all the machines on the network. Think of it like being in a crowded room where everyone can hear someone shouting. Then you have point-to-point networks. These involve direct physical layer protocol transmission between 2 very specific points, much more like a private phone call. And here's the kicker. TCP has to seamlessly govern data packets across both of these physical realities.
And honestly, the specific environment where all this happens matters immensely for your exam scenarios. Whether you're dealing with a closed internet, one that's tightly controlled by a single admin for authorized users only, or an extranet acting as a protected portal, or even the vast global internet. TCP is the common language for the whole shebang. It makes sure your data gets exactly where it needs to go, totally free of corruption, no matter where those network boundary lines are drawn.
So, you're probably wondering, how exactly do we piece all of this together to actually bag full marks on a really tricky scenario question? Well, in just a moment, I'm going to reveal a hidden examiner clue that will literally change your answer completely. But first, we need to set up the framework that makes that specific clue incredibly obvious. Because without this framework, you're just memorizing theory. And trust me, that is never enough.
Which brings us to part 2, the top mark framework. Let's look at exactly how to structure your perfect answer.
To actually score those top marks, instead of just kind of throwing buzzwords at the exam paper and hoping they stick, we've got to apply this specific framework. Just look at the exact progression here for a perfect answer. You don't just state the core concept, which is TCP/IP. No, you have to actually describe the technical mechanism that it governs packet routing. Then you apply that directly to the scenario example they give you, like an intranet portal. After that, you clearly state the consequence or advantage, which is error-free exchange. And finally, and this is crucial, you lock it all in with the exact examiner wording. Ensures reliable data transmission. If you can mentally hit those 5 steps, your answer is going to be absolutely bulletproof.
All right, part 3, interactive exam challenge. It's time to actually apply this framework.
Let's escalate the stakes of it and test your retention with a quick pause and solve challenge based on a very realistic Cambridge network scenario. I want you to pause this explainer right now. Use the framework we literally just covered to compare an intranet secure data transmission to a broadcast network using a shared channel. Really try to formulate an answer using those exact technical terms we discussed. Go ahead, pause it, and think it through for a second.
Okay, assuming you've got a solid answer in your head, let's look at a critical layer you absolutely needed to include. To hit those absolute top band marks in these complex networking questions, your answer must recognize the session layer's role. This is where connections are actually made, maintained, and ended. It acts kind of like an announcer. Specifically, it handles dialogue control, meaning it decides if the system enters half duplex, where communication is just one way at a time, or full duplex, where it's communicating two ways simultaneously. It also handles synchronization by adding these clever little checkpoints into a stream of data. That way, if a crash happens, the transmission can just resume right from the checkpoint instead of starting all over again from scratch.
Let's move to part 4, Examiner Feedback Upgrade. Let's build that perfect answer.
Okay, so let's see how your mental attempt actually stacks up against the required mark scheme. There is a stark contrast between a weak generic guess and a high-level answer that applies specific scenario constraints. A weak answer might just say, TCP sends data securely to the internet. Again, that gets 0 marks. But a top-tier answer, it says, TCP/IP governs packet routing for reliable, error-free data exchange within the specific internet constraints. Do you see the difference? It hits the mechanism, the consequence, and the specific scenario all in one perfectly fluid technical sentence.
So, that hidden examiner clue I promised you earlier? Here it is. You must physically anchor your technical TCP knowledge directly to the specific scenario nouns provided in the prompt. I mean it. If the exam question talks about a hospital's intranet, your answer absolutely must mention the hospital's intranet, not just some generic network. As this quote perfectly emphasizes, generic answers are inherently weaker and will always lose marks in Cambridge assessments. You really have to weave your facts into the actual reality of the scenario they give you.
And hey, to make sure you never miss out on these hidden exam strategies and technical frameworks, make absolutely sure you're subscribed to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. But listen, fixing your TCP definition and knowing how to anchor those scenario nouns, that's really only half the battle. Just think about this for a second. If TCP guarantees error-free delivery, what happens when a network's physical hardware fundamentally fails? When you encounter a question that doesn't just ask you to describe TCP, but actually ask you to evaluate a failing network setup, well, the entire game changes. To secure the absolute highest grade, you must know the correct evaluation pathway. You need to know exactly how to structure an argument that perfectly weighs pros, cons, and technical constraints. And that is exactly what we crack wide open in our next explainer on the top-bound evaluation framework. So, click on the next explainer right now, and let's go lock in those evaluation marks. I will see you there.